Hello everyone, in this video I'm gonna make some sodium dichromate from stainless steel. I lost the footage, but I dissolved some stainless steel in HCl, hence this greenish dark solution. In this Fanta bottle, as you can see, there's a little bit of green solution left, but I'm gonna probably dispose of that later. I'm gonna mix it with sugar and boil it down to a slurry and keep it in bottles for waste. So first, what we need to do is make some sodium carbonate. So I'll get the oven. Okay, so now I've got my oven. I'm using it as a lab oven because a lab oven costs a lot. I'm kind of nervous using it because it's my first time. So let's open it up. I need some sodium carbonate, so we'll cook the daylights out of some baking soda from this jar. I just took some baking soda from my home and put it in this jar because it's sodium hydrocarbonate or sodium bicarbonate. I'll just put a lot of it into this tray, and I hope, as you can see, most of it is in there. So now I'll close my jar, put it away in my spatula. I don't think this is needed. The last time my synthesis failed in this step, so I think I'll just put this here and I'll make it more leveled and close it up. And I'm gonna now plug in it into the outlet. Come on. Okay, so now let's turn it on for around 120 degrees Celsius and 15 minutes. As you can see, it's on. I'll be back when this will be cooked. Okay, so now the timer just stopped. I set it actually for 20 minutes and not 15, but let's open it up. It actually smoked a little bit at the start and filled my lab with some smoke. That's probably just the heating element coating burning off. Now I'm gonna open it. I'm gonna unplug it just in case something fails and it turns on. Okay, let's remove. See how powdery that is? That's literally like sand, not like a powder, but like sand. So this should be some pretty pure sodium carbonate. So now I will take out this metal piece. It looks like it came from one of those big ovens. I'm gonna close the door and put it down because it's really hot. But look at that. Look how green it is. I have thick gloves so I can touch it with no problem, as you can see. But this is quite dangerous to do in a food oven, because just in case, just don't use chemicals for food oven. I literally bought this oven, I got it for my birthday to do some chemistry with it. This is the first thing I'm using it for, just making some sodium carbonate and dehydrating it. It could be in a solution, but I want it more concentrated, so now I'm gonna pour it into it. Oh my god. I don't have any space to film it and pour it, so that's why I have allowed this on my desk. So now I'm gonna react it with the solution. Okay, now I have this solution, and now I'm gonna pour the sodium carbonate after cooking it in small portions to see how does it react. Doesn't seem to react a lot. Maybe it's not just mixing well or something. Oh, that's weird. I think most of the acid is probably neutralized. Can you see that? It's getting a lot greener, I think. It's changing in some way. I'm gonna grab a stir stick. Or maybe I can... Yeah, I think I can use this little stainless steel mantle. Oh, can you see that bubbling up? Yeah, that's the reaction I'm hoping for. Yeah, so that's neutralizing the acid and other stuff. And this is how I'm gonna make my sodium chromate. But I have to warn you, sodium chromate is carcinogenic and really toxic, so don't try this at home. So now I'm gonna just let it react like this off camera, and then I'm gonna mix it with some sodium hypochlorite. Okay, so now it has precipitated a lot of metal hydroxides. I'm gonna filter them after adding this, which is, as you can see, sodium hypochlorite, or A's bleach. So now I'll add the bleach in small amounts until it gets a rusty color, and then I'm gonna filter it, and that should give us our sodium chromate, which I will acidify to make sodium dichromate. Oh, I can smell chlorine, so I'm gonna open the door now. Okay, so now we have ventilation. I think this actually produces chlorine. Yeah, I can smell chlorine, yeah. We have chlorine now in the lab. And I don't have my gas mask on, but oh well. I'll add a little bit more and that will be enough, I guess. Because I don't know how to measure anything here. I'm just eyeballing it for now. I mean, oh no, I hope it doesn't overflow. But this is actively bubbling. I hope this is not pure chlorine, because I can smell. Oh no, I hope this doesn't bubble over. Oh yeah, that's such a strong smell. I'm gonna stir this for a while. Okay, so now I have it set up in a filtration setup. I'm just filtering the iron oxides and hydroxides from this, but the drops seem not colored, so I don't know. I'm gonna pour more of this. I'm gonna leave it to filter like that, but although I can see maybe a little yellowish tinge, so I think it's actually working, so let's wait. Okay, so now I've filtered most of this goo. This is gonna done filtering. When this will be done filtering, I'll pour more of this goo, and then when all of this will be filtered, I will wash it with some water from my wash bottle down there to remove any chromium salts that are left, mostly sodium dichromate, which is this yellow liquid. I mean chromate, this is sodium chromate. I will turn it into dichromate. And warning, hexavalent chromium of oxidation fourth state is really carcinogenic and really dangerous. I will wash this and remove all of the carcinogenic chromium salts from this, and then throw out the iron oxide into the trash can, and all of the waste will be kept in this bottle so that it doesn't go into the environment. I'm gonna try to find a disposal site of dangerous chemicals as this. So let's cut to the point where I'm done. Okay, so now we have the chromate solution, which I will use Oh, my light is kind of not the right one for filming, but oh well. So now I'll use my separatory funnel to drip some sulfuric acid into it slowly in small amounts because my pipette broke and it seems that it's stuck. Yeah, it's stuck. I don't want to break it, so I will just take a, I think actually I can use a, oh look, I found a glass rod. I will use that as a pipette. So I have this battery electrolyte which I labeled at 30%. It has some condensing going on because the lab is really cold, but I turned on a electric heater and now it's really warm in here actually. So I like it here because it's really warm and I really like it. So now I'll try to take some of the sulfuric acid. Just gonna get a drop, put it in. Nothing happened. Okay, so now that the solution has done filtering, I'm gonna convert it into some dichromate because if you can see, it's yellow, and I'll take some of my 30% sulfuric acid from the last video or car battery electrolyte and drip it in very slowly and mix it. For some reason nothing is happening. I added some of it in my broken pipette which I fixed with my blowtorch. That's why it's really flimsy. What do you think? Is it orange? I think not. I'll add some more sulfuric acid to it because this is dilute. Nothing is happening. I guess we need more acid, but I'm scared to form some chromic acid. Well, I guess it's more orange and cleaner. I mean, it's getting there. I'll add some more. I don't know actually a lot about this step of the transition from chromate to dichromate. Oh. But I know that it should happen in low pH solutions, and people that I have seen have done it easily with, I mean, is it orange? I mean, if I take it to my light, it's kind of orange. Okay, that's weird. Let maybe more sulfuric acid to it. Okay, I think that's all I'm gonna add for safety reasons, to not form some chromic acid, which would be kind of disaster for me. I think it's probably good, or no, I could try putting in maybe some more. Nothing is happening. I'm gonna put in more and that's gonna be all. Yeah, I think maybe I need it to boil down because the yellow is kind of more concentrated now and it's looking a lot better, so maybe I need more sulfuric acid. I'm gonna add a little bit more and I will boil it down. If it's not orange when I will boil it down, that means I will need it's not. Yeah, I don't know, for some reason it's just not getting orange or the color should be. Okay, now let's boil it down. Okay, so now I'm gonna boil down the solution. I'm gonna turn on my hot plate up to the max and let's boil it down. Okay, so now that the solution is boiling, change colors again. I think it's due to the impurities. I think I will get probably chromate, not dichromate. But if it will be orange, then it will be okay. If when I will boil it down a lot, it will be not orange, I will add some more sulfuric acid or maybe even hydrochloric acid. But I mean, oh, that's hot. That's too hot to touch. But it's actually pretty orange after starting to boil, so I hope it goes well. So we'll meet you then. Okay, so now also I turn off the heating for a bit. Now I'm gonna add a drop of concentrated HCl because I don't know, but the color is not that orange as it should be, and I think my sulfuric is just maybe neutralized by the sodium carbonate content in this. So I'm gonna take some hydrochloric acid. And I mean, it kind of changed colors. Oh yeah, that's really red, yeah. Oh no. Oh no, I dropped a sulfuric acid drop somewhere. Oh no, but I mean, hydrochloric acid doesn't eat at wood, so, or at least not like erode it or anything, so I'll add some more hydrochloric acid to it and I'll be done. Okay. So now let it boil down and I'll put it in some snow to cool it down. Okay, so now I remove the flask from the hot plate. If I would have a light, a bright light, you would see that it's really orangish. But I mean, something just does not add up. Maybe I'll take a drop of concentrated hydrochloric acid once again, and then I will put it in some cold, really cold temperatures, or a bottle of, I mean, not a bottle, how do you say it, a pot of snow. Now I'm gonna put away the rest of the acid. And put away the hydrochloric acid bottle. So as you can see, it's a bright orange color. Not actually pretty, not too orange. I mean, probably gonna add even more before putting it, because it's almost boiling actually right now. I mean, it was boiling a few seconds before I started filming, so it's more hydrochloric acid. And I'm gonna leave this as it is for some time. Okay, now I'm gonna take a pot with some snow and put the beaker into the snow. So now I have a pot with some snow. I'm gonna put away the hydrochloric acid. So when I will jam the flask into the pot, the word jam just reminded me of a jam jar and of that YouTuber Jam Chemist. He's a French chemist. Yeah, and he did a similar video. I mean the same, but I'm using a different method. I'm just gonna, this snow solidified into basically ice, so I'm gonna just make it fluffy again, like this. Now, as you can see, I have my beaker with the yellowish solution, and I think I'm gonna add some more acid off camera, but now I'm gonna try and fit my flask, my beaker. Let's just say beaker, okay, not a flask. Why I always say flask? This is a beaker. Yeah, this is hard. Larry, I haven't done something that messy for a video in a while. I mean, like a few years. Because I remember filming things that required me to whack things with a hammer that didn't go into YouTube because I didn't have a YouTube channel and I have it on my old broken iPad because it really shuts down after some time, and the rest is on a GoPro camera, which is too hard to use it for YouTube because you can't just take the data and transfer it to you cannot even transfer it to a phone, only into a computer, and that's not good. So now I'm gonna just put the flask in here and leave it for some time. Okay, so now after the hydrochloric acid addition and the boiling down and putting it in some snow, it crystallized out, but those crystals are white if you can see them at the bottom. So this is only chromate. I think the problem is the salt, so I will pour them off. I will pour the yellow sodium chromate off, and but what salt could it be? I will try to dissolve it in some water with my washing bottle. It's a homemade one. I'm gonna in the future make a video about it. And the salt seems to be soluble. Yeah, the salt is soluble in water, but what could it be? Then I don't know, but it's an impurity that I will put back. Now this is our carcinogenic sodium chromate, and I will boil it down for another time. So I will grab my hot plate and put my beaker and turn on heating, and after it will be saturated, I will put it in another snow bath. So I will be back. Okay, so now after some boiling, I have this solution with that should be really pure, and it's dichromate because it's really orange. So now I'm gonna turn off my hot plate and put it on the ground so I don't step on it or touch it. Now I have my concentrated boiled down solution and my pot with some snow again, and now I'm gonna just put it in the snow. I mean, first I'm gonna let it cool by itself so the glass doesn't crack, and then when it stop fuming, I will put it in the ice. I think now I'm gonna put it in. Anyways, this is borosilicate glass, so it can handle the heat. Like this, I'll dig a little bit. I will place it like this, and I'll let it sit for a while until the crystals crystallize out. Okay guys, I just looked into the pot and I was really ecstatic. I mean, we didn't make any dichromate, but we totally made some sodium chromate, not dichromate, but anyways, it will still be fine. I think it's contaminated with something, but in future, I think maybe even probably this week I will try making some chromium trioxide, but I think not, because I finished with my new lab, but I still have some work to do, so not probably gonna do anything, so I'm gonna put the pot away. And now look at this, look at the crystals. They're so yellow. Yeah, they're wet, but they're still so yellow. They're just beautiful, basically. I really like them. So now I have this polypropylene plastic container, which I'll put the wet dichromate. I mean, because it's wet, it's not that great, but I think it's pretty good actually for what it is. So now I'll take another container. Yeah, I cannot find the container that I want. Oh, I found it. Come on, where is it? Okay, so now I finally found the container that I'm going to use. It's just a jar. I was storing vinegar in it, so the solution could turn red. But there we go, some sodium chromate solution. I'll just drain this off. Okay, so now I think that's all done. And now I will close it with this big stopper. And let's remove the sodium chromate. I really wanted to make chromate, sodium dichromate, not chromate, but things happen, and it's really late, and I need to go home. I also want to do some job before going home, so just pour off this sodium dichromate solution. It probably contains impurities. I think I will use this solution as the starting point on making the sodium, the chromium trioxide. Although I think off camera I will try to convert it into dichromate, okay? Because this is actually too much footage for a video. So, okay, let's put it into this cup. Let's put this cancerous goo of crystals and wet with water. I'm gonna probably stick this into a desiccator and let it dry, probably. I mean, I don't have a desiccator, but I can just put this into a jar and put some sodium hydroxide at the bottom, and it will be a desiccator. Okay, so now I have all of this stuff, this cancerous crystals. There's some water that's separated from them, so I'm gonna pour out more of the liquid. Oh no, I put one of my big crystals. I'm gonna remove it. Oh, dissolved. You know what, that will be okay. So now I will just put this in the desiccator, but see how much of sodium chromate crystals we have, and it's a beautiful yellow color. So like always, don't forget to like, share, and subscribe, and see you next time. Bye!